Welcome to Pharmacology Outline channel. In this video, we will take overview of the life cycle and regulation of acetylcholine, a key neurotransmitter involved in various functions such as muscle activation and autonomic nervous system signaling. Let's start the processes step by step. 1. Synthesis of acetylcholine. Acetylcholine is synthesized from choline and acetyl-CoA, a reaction catalyzed by the enzyme choline acetyltransferase. This is a vital starting point for acetylcholine production. 2. Storage in vesicles. Once synthesized, acetylcholine is stored in synaptic vesicles within the neuron. The vesicles protect it from premature degradation, ensuring its availability for transmission. 3. Release into the synaptic cleft. When an action potential travels down the neuron, calcium ions flood the presynaptic terminal, triggering the fusion of vesicles with the membrane. This process releases acetylcholine into the synaptic cleft, the space between neurons. External factors like botulinum toxin can inhibit release, while spider venom can enhance it. 4. Binding to receptors. Acetylcholine then binds to specific receptors on the postsynaptic membrane, either activating or inhibiting the postsynaptic neuron, depending on the type of receptor. 5. Degradation of acetylcholine. The neurotransmitter is rapidly broken down in the synaptic cleft by the enzyme acetylcholinesterase. This step is crucial for terminating the signal and preventing overstimulation. 6. Recycling of choline. Choline, a byproduct of acetylcholine degradation, is transported back into the neuron for reuse. This recycling mechanism is essential for maintaining efficient neurotransmitter synthesis. Notably, certain inhibitors, like hemocholinium, can block choline uptake. In summary, the life cycle of acetylcholine is a highly coordinated and regulated process. Each step is critical for precise and reliable cholinergic neurotransmission, which underlies a vast array of physiological functions. Disruptions at any point in this cycle can have significant and often detrimental consequences for the nervous system and overall bodily function. Thank you for watching. If you enjoyed the video, please like and subscribe for more pharmacology insights. Hit the bell to stay updated. Keep learning.